Welcome to day 15 of calculus. Today we're going to work with the derivative function, but to get to working with the derivative function, we need to first fill in this table. There are a bunch of things that need to be filled in. The first one is sheerly the function f of x evaluated at all of these x values. So what happens to f of x, which is right here, when you plug in -2? So when you plug in -2, I'm talking about 3 times -2 squared, which is going to be 3 times 4, which is indeed 12. The next one's going to be 3 times -1 squared, which is 3. And if you go along plugging in these x values into the original function, you end up with 3, 12, 20, 12, yep, that's right, 27, and 48 when you do it out. Now the next part is a little trickier because it's asking you for the f prime, which you can call it f prime. You can also call it the derivative of f at x, or the instantaneous rate of change of f at x. And the way we've been doing that is the following. We've been calculating the limit as h goes to 0 of f of a plus h minus f of a all over h. So let's do it for the first one here when x is -2. So when a is -2. So that's going to be the limit as h goes to 0 of f of -2 plus h minus f of -2 all over h. Well, we already know what f of -2 is, and that's this 12 right there. So if we plug in what we know, we end up with the limit as h goes to 0 of f of -2 plus h minus 12 over h. Now we need to find out what is the function evaluated at -2 plus h. What's the function evaluated at -2 plus h? Well, the function is 3x squared, so that's going to be 3 times, in this case, -2 plus h squared, so that's 3 times, you get -2 squared is 4, minus 2h plus h squared. You end up with 12 minus 12h, because these two is -4, -4 times 3 is -12, plus 3h squared. So this right here ends up going in right there. So when we write it out, we end up with the following. Again, what we just found is right here. We just put it there. What's nice is that the 12s cancel, which is what we're looking for, leaving us with the limit as h goes to 0 of -12h plus 3h squared over h. What can you factor out? We get the limit as h goes to 0. You can factor out an h from the numerator, and with -12 plus 3h all over h, it cancels, and you're left with the limit as h goes to 0 of -12 plus 3h. h is going to 0. We can plug 0 in for h now, and we just end up with -12. So we did all of that work, so that -12 could go in right here. Now theoretically, we could keep on running this limit over and over and over again for each of the remaining 6 numbers that we need to find the instantaneous rate of change at, or we could see if there might be a faster way. Well, we're going to have to run the limit one more time, but instead of plugging in, say, -1 and then 0 and then 1 and then 2, let's just plug in any number. And what we're going to do that, we're going to do that by calling that number a. So if I had the limit as h goes to 0 of f of a plus h minus f of a, and instead of plugging in -1, 0, 1, 2, 3, 4, we're going to treat a and h as regular numbers, just as a number. And the function again is 3x squared, 3x squared. So in this case, f of a is going to be 3a squared, and f of a plus h, what's that going to be? That's going to be 3 times a plus h squared. If we multiply that out, we end up with a squared plus ah plus plus h squared, which is 3 times a squared. You have 2 of those, plus 2ah plus h squared. You end up with 3a squared plus 2ah plus, 6ah, 6ah plus h squared. Now keep in mind that this is the function evaluated at a plus h, which is right there. And we also found out that f of a is 3a squared, so that goes right there. So if we plug this all in, we end up with that. So again, this went there, and the yellow is all the same right there. Does something cancel similar to what canceled before? Yeah, the 3a squareds cancel right there. And now what you're left with, this blue limit, the limit as h goes to 0 of 6ah plus h squared over h. What can you factor out of the numerator? It's very similar to work to what we just did, but a could be any number. So you have h times 6a plus h over h. Just like before, the h's cancel. And now, can you plug in 0 for h? You sure can, because what we have here is the limit as h goes to 0 of 6a plus h. And when you plug in 0 for h, now you end up with 6a. What this tells us is that if we want the instantaneous rate of change of this function, 3x squared, all we need to do is multiply the a value by 6. Let's go back and look at this one. We did all that work before to find out that the instantaneous rate of change was negative 12. Well, what is 6 times negative 2? Well, it's negative 12. So this tells us that if the a value is negative 1, the instantaneous rate of change is going to be negative 6. Well, what's 6 times 0? Well, that's 0. 6 times 1 is 6. 6 times 2 is 12. And 6 times 3 is 18. And 6 times 4 is 24. Effectively, what we've done is done this limit once, keeping, instead of plugging in a number for a, just keeping the a value in there and coming up with this answer. There's no h in it at all. It's totally dependent on the a value. And a value could be anything you want it to be, anything in the domain. Another way to write this is to say that the instantaneous rate of change of the function at x is going to be 6 times x. The instantaneous rate of change of the function x at x is, the function f at x is 6x. This is the derivative. This is the derivative function right here. This is the derivative of f. This function gives you the rate of change, instantaneous rate of change anywhere on the domain. You just have to multiply any of the x values by 6. So let's do one that's similar, but a little bit more involved. Again, you start by writing the same thing down. The limit as h goes to 0 of f of a plus h minus f of a all over h. You need to find out what f of a is. Well, that's plugging a into the original equation, so that's going to be 2a squared plus 3a minus 5. So we found f of a. Well, let's find f of a plus h. So that's going to be 2 times a plus h squared plus 3 times a plus h minus 5. Let's do a little algebra and multiply this. So when you multiply this out, you end up with a bunch of terms, and you look for like terms to see if you can simplify this anymore, but unfortunately you can't. Unfortunately you can't. So it's a little ugly for now, but hopefully it is going to collapse. So this part is f of a plus h. So all I've done here is rewritten, I've taken the evaluating the function at a plus h and put it there, and evaluating the function at a and putting it there. Let's see what cancels. A whole lot cancels, and you're just left with 4ah, 2h squared, and 3h, which is great because what does that mean? You can now factor out of the numerator. You can factor out an h, not a 4, an h. So it's h times 4a plus 2h plus 3 all over h. Now what cancels? Oh, this cancels. We're almost done. We have a limit as h goes to 0 of 4a plus 2h plus 3. If h is going to 0, this term goes to 0, meaning you end up with 4a plus 3. So what this means is the derivative of the function is 4x plus 3, meaning if you want the instantaneous rate of change at any part of the domain, so what is this, f prime? F prime is this function right here, is this function right there. So what could we do with this? What's the instantaneous rate of change of this function at 1, or at 2, or at 3, or at 4? You can just plug in 1, 2, 3, or 4 into this function, and you don't have to do all of this work again. You do it once, and you find the derivative function once. In our first example, we figured out that if f was 3x squared, the derivative was 6x squared. And in the second, we found out if the function was 2x squared plus 3x minus 5, the derivative was 4x. I want to see if you can figure out what the rule is to go from one function to the next, to go from one function to its derivative. And my hint is take a look at the leading coefficients and the powers. Leading coefficients and the powers. Take a look at those and see if you can come up with the rule. It's something that'll be really, really helpful. Let's look at this example. A person walks away from home on a north-south path. So this person's going up and down. So north and south. His distance from home is given by the formula d equals f of t equals t squared plus 6t, where t is in seconds and f of t is in feet. Evaluate and interpret the following. So what does f of 1 mean? Well, that means his distance from home at 1 second, after 1 second. What does f prime of t mean? Well, that's the instantaneous rate of change of his position at time t. Let's go back to A for a second. It says evaluate, so we just plug in 1. So f of 1 would be negative 1 squared plus 6 times 1. Remember that negative sign is happening after the squaring, so that's going to be negative 1 plus 6 is 5. This means he is 5 feet from home after 1 second. 5 feet from home after 1. So if you wanted to find f prime, you could run the limit like we did before. I'll just tell you what f prime is going to be this time and see if you figured out what the pattern is. The derivative in this case is negative 2t plus 6. So when we knew that this was the function, this is the derivative. Again, pay attention to the coefficients and the exponents. And the invisible exponent is the one right there. So the instantaneous rate of change of position at time t is f prime of t. Another way to say it is how fast he is moving away from home. So what does f prime of 1 mean? Well, that means the rate of change at time, rate of change of what? Of what at time 1. And it's rate of change of position. Another way to say it would be the rate of change of the person moving away from home. And what's that going to be? Well, you plug in 1 into this function. So f prime of 1 is going to be negative 2 times 1 plus 6, which is 4. So what does that mean? It means the person is moving north because the value is positive. This is a rate of change. Rate of change. So the person is moving north at a rate, and what's the unit? We're talking about seconds and feet. So this is going to be 4 feet per second. So the person is moving north because it's positive. What about f prime of 5 when f prime is negative 2t plus 6? So that's going to be f prime of 5 is negative 2 times 5 plus 6, which is negative 10 plus 6, which is negative 4. Since it's negative, so this was north, this person is moving south at a rate of 4 feet per second. So you can either say he's moving at negative 4 feet per second or moving south at 4 feet per second, one or the other. So north, south. Kind of assume that up is north and down is south. Likewise, to the right is positive, to the left is negative.